Hello everyone, today we're going to multiply radical expressions. So in multiplying radical expressions, there are three cases to be considered. Number one, if the indices are the same. Number two, if the indices are different, but the radicands are the same. And then number three, if the indices and radicands are different. Okay, so these are the three cases to be considered in multiplying radicals. So when we say indices, this is the plural form of index, and then radicands, we have, this is the plural of radicand, the word radicand. And what are these indices and radicands? So let us have a review of the given expression, the nth root of a raised to the m power. So n is what we call the index. This is the radical symbol or the radical sign. Then a is the radicand. And then m is the exponent of the radicand. So let us have now an example of multiplying radical expression. Given number one case, if the indices are the same. So number one, let us give the product of the square root of 6 times square root of 5. So here, what are you going to do is we're going to make use of the product rule for radicals. Remember the product rule for radicals, wherein if we have a square root of x times square root of y, what are we going to do is we're going to multiply the radicands. So we have square root of xy. Okay, so given the square root of 6 times square root of 5, so if we're going to multiply, that is square root of 30. Okay, so we have 6 times 5. So we have here square root of 30. Okay, so this is now the simplified form of number 1, square root of 6 times square root of 5. Next, number 2. Let's say we have square root of 32 times square root of 2. Okay, so again, using the product rule for radicals, we have square root of 32 times 2. Okay, you can make use of that also. So, but then here I make use of, or I use parentheses. So we have 32 times 2, we have 64. So square root of 64, we have 8. Okay. Next, number 3. Let's say we have square root of 27 times square root of 2. Again, using the product rule for radicals, we have 27 times 2. Okay, so we have here 54. Now, as you can see, 54 has factor wherein it is a perfect square, right? And what is this factor? We have 9, right? So factor 54. So factors are 9 times 6. Okay? So 9 times 6 is 54. So square root of 9, we have 3. Then you will just copy square root of x. Okay? Next, number 4. Let's say we have square root of 3x times square root of 12x cubed. Okay, So here, again, using the product rule for radicals. So let us now multiply. We have 3x times 12x cubed. Okay. Then 3 times 12, that is square root of 36. Then x times x cubed. So we have x raised to the 4th power. Remember, if you have x raised to the m power times x raised to the n power, what are we going to do with the exponent? So we just add the exponent. So we have x raised to m plus n, right? Okay. So we just, here, going back to our example, we just add the exponents 1 and then 3. So the result is 4. Okay. Then square root of 36, we have 6. Then x squared, right? Because square root of x raised to the 4th power, so we just divide the exponent to the index. So we have 4 divided by 2, we have 2. Okay? Next, number 5. Let's say we have 5 square root of 8 times square root of 2. Okay. So here, we're going to multiply the coefficient to coefficient and then radicand to radicand. So we have 5 times 1, we have 5, okay? Then times 8 times 2, we have 16, right? But then let us write the step-by-step process. So we have 5 square root of 8 times 2, we have 16. Then 5, we all know that 16 is a perfect square, so square root of 16, we have 4. Okay, so 5 times 4, we have 20. Okay, number 7. Let's say we have 3x square root of 3 times 4x square root of 6. Okay, so what are we going to do is we have to multiply the coefficient to coefficient and then radicand to radicand. Okay, so we have 3x times 4x, then square root of 3 and then 6. So we have 3 times 6. Then let us multiply 3x times 4x. We have 12x squared. Then 3 times 6, we have 18. Then copy 12x squared. So notice that 18 is not a perfect square, but then let us find the factors of 18, wherein one of its factors is a perfect square. So we have 9 and then 2, right? So we have here 12x squared. Then times square root of 9, we have 3. So multiply it to 12x squared. Write it outside the radical symbol. Then copy square root of 2. So we have 12x squared times 3. So we have 36x squared. Then you just copy square root of 2. So that's the answer for number 7. Next, number 8. Okay. Number 8, let's say we have cube root of 5x squared y times cube root of 25x squared y squared, or y raised to the 5th power. Okay, so again, notice that the indices are the same. Okay. So here, or the index are the same. So here, what are we going to do again? We have to multiply the radicand. So we have cube root of 5x squared y times 25x squared y raised to the 5th power. Then let's multiply. We have 5 times 25, we have 125. Then x, you're going to make use of the product rule for radical. So we're going to add the exponents. So we have x raised to the 4th power. Then y. We add it again. We have 5 plus 1. So we have 6. Okay. Then equals to. So notice that 125 is a perfect cube. X raised to the 4th power is not a perfect cube, but then has factors wherein one of its factors is a perfect cube. Y raised to 6 is a perfect cube. Why? Because 6 can be divided by the index 3. Okay? So, we're going to factor x raised to the 4th power. So, we have here, okay, 125. Then, for x variable, so you're going to look for a number less than 4, which is divisible by the index 3. So we have x cubed. Okay? Then the remaining x raised to the 1st power, you have to write it here on the non-perfect cube factor. Then y raised to the 6th power. So 6 again, 6 can be divided by 3, so that is a perfect cube. Then after that, let us now simplify. Cube root of 125, we have 5. Then x, you divide, 3 divided by 3, we have 1. So no need for us to write here x raised to the 1st power or x raised to 1. Then y raised to 6 divided by 3, we have 2. So y squared. Then just copy cube root of x. Okay. So this is the answer for number 8. Okay. Next, number 9. Our last number. Number 9, let's say we have 3 cube root of 9xy cube times cube root of 3x raised to the 4th power y raised to the 5th power. Okay. So multiply 3 times 1. So that is equal to 3. Then cube root of, again multiply, 9xy cube times 3x raised to 4 y raised to 5. Okay. Then copy 3. Cube root of 9 times 3, we have 27. Then x, we add 1 plus 4. So we have 5. Then y, 3 plus 5. So we have 8. Okay. Then copy 3. Cube root of, again factor 27. X raised to the 5th power, y raised to the 8th power. So we have factors of 27 wherein one of its factors is a perfect cube, but then 27 is a perfect cube. So you have to write it here. Then for the x variable, so we have to think of a number less than 5 which is divisible by 3. So we have 3, right? So x cubed. The remaining x squared, you have to write it here on the non-perfect cube factor. Then for y variable, again, think of a number less than 8 divisible which is divisible by 3. So we have 6, right? Then the remaining y raised to the second power, you have to write it here on the non-perfect cube factor. Then we have 3. Let us now simplify. Cube root of 27, we have 3. Multiplied it here, we have 3. Then cube root of x raised to the third power. So we have x, because you divide 3 divided by 3, we have 1. For the y variable, we have 6 divided by 3, we have 2. Okay? Then, you just copy cube root of x squared, y squared. Okay. Then, let us now multiply 3 times 3, xy squared. So, we have 9xy squared. Then, you will just copy cube root of x squared, y squared. Okay. So, that's it for number 9. So, that's it for today. We're done with multiplying radical expressions. Given the first case, if the indices are the same. So, don't forget to like, comment, subscribe, share, and click the notification button for more videos and updates. Thank you.